Today we'll go to the chapter number 8 in our book. We talk about fit as amplifier or AC of fit. AC of fit. Okay. Just make quick revision if you remember. Where's the note? Here's the note. This is the note. I'll use my pen to write. Okay. Yeah. Usually, when we studied anything, for example, for BGT, we started from physical, then DC, then AC. And for DC, we studied three models: fixed bias, self bias, and voltage divider. For AC, this also we studied three models: RE model, hybrid model, and R-pi model. Okay, now for fit, on another side, this is fit. Also, we studied physical. We studied, first of all, G fit. So you can see roadmap. This is also MOS fit. We studied two things: depletion and enhancement. Then we studied DC. We studied also fixed bias. Also, we studied self bias, voltage divider. So now where we are here in AC. So as you see, if we make a comparison between this and this, for AC in BGT we have three models: RE model, hybrid model, and R-pi model. So today we'll study AC model or GM model. So today we are here to finish strip. We start with BGT as you see here. Then we went to the fit. Today we're gonna to start GM. Okay. Now, why I need AC model? As you know, it's an AC model. This is from me. It is a model, but for linear device. Like linear device like R, C, DC volt to work like non-linear device. Non-linear device like transistor, BGT, or fit. So now, what is the model that we're going to find for fit? This is our lecture today. Today we will find model, AC model. Is it clear until now? Any question for this? This is our topic today. So what is the AC model? So this is our job today. Any question for this? No. Good. So let's return back to our book. And here we are. Large volume. So GFIT small signal model. The gate to source voltage control drain source kind of GFIT. Okay, I don't need this one. If I take delta ID over for GM, if you know this, if I take, I know ID equal GM VGS delta ID equal GM delta VGS. So if I take small changes in delta ID, with delta gives to me something called GM. John, what is GM? GM here, from circuit theory, if you remember, we have R. R. R, it is volt over I measured by O. Here we have G. What is G? Is I over V measured by Siemens or O minus 1. So we're gonna use G. This G. It is delta I over delta V, or it's I over V measured by Siemens or O minus 1. This is called, we have resistance and we have conductance. So this is conductance. So the first thing today is, or that we will find today, this one. I want to find GM. Wait, let's think. I prefer this method in BGT comparison in FIT. Ahmed, in BGT we have RE, correct? In BGT I have RE, correct? Where Ahmed? Here we have GM. Here we have GM. So in BGT I have to calculate RE. In FIT I have to calculate GM. Got the idea where I'm talking about? So we have something to calculate to start. There you have to calculate RE. Here I have to calculate G. If you remember IE, it was VT over IE, or RE, it was 26 millivolt over IE. This is IE DC current. Correct? Do you remember this? All good. Now, what we have to study here, I have to study or calculate GM. So now how I can find GM? Delta over delta. Delta over delta, we can use this graph. Delta over delta. So I can take delta from 2 points and find delta. This is a little bit hard for AC. For DC, you must draw. But if I want to apply this for GM, it's a little bit hard. So how we can solve this one? Here, see, determine the magnitude for GM with ID and VB. So here you can calculate delta over delta, delta over delta. Delta over delta. But it's absolute, I have to select 2 point, random 2 point to make or calculate this a little bit hard. So here we are. This is very important. I need this. Mathematical definition of GM. Again, repeat idea. We start with BGT, physical, DC, then AC. Then we went to MOSFET, physical, DC, AC. For AC, if I want to make a comparison between BGT and FIT, in BGT we started with RE, if you remember. Now we have to calculate here another thing, another parameter called GM. So we have RE in BGT, we have GM in FIT. Okay, thank you so much. For GM, we have two methods. GM by definition is this, delta over delta. Stop. So I can use a graph like here, but this is a little bit hard, so I don't need an exam. I need mathematical issue. Until now, it's clear for us. Any question for this? With me, step by step. How can I calculate mathematical issue? I will start with GM. It's di over d. I don't need this mathematical. So ID, it's ID is S1 VGS over minus VBO square. Take D for VGS. So here we have squared out, here 2. Then here we have 1. ID is S, 1 minus VGS over VB. D for this. Again, last result is this one. So GM as a mathematical, it is 2I ds over absolute 1 minus VGA over VB. All absolute. Don't forget first. Absolute. Repeat, absolute. Again, we call this part G M O or G maximum. See, because here we have a minus, so decrease. So we call 2I DSS over VB, it is GMO. Then you have VGS over VB. So where is VGS? VGS is given, or we can select it based on IDS is given, VB is given, so we can find GM. See here also, VB here with sign, VB here absolute. This is your mistake in exam. Okay. We called the GM0 as 2IDSS over VB. Until now, any question, I don't need this mathematical, just explain how we define this one, mathematical. So in exam, you have to solve as a mathematical, not in this, see, in DC, graphical, here, mathematical. Is it clear? Is it clear? Okay. Now, for GFIT having the transfer characteristic of example 8.1, find the maximum value of GM. Where is this one? Here. He gives to me IDSS and gives to me VB. Then at each point, VGS. So here we have to calculate GM0. Then you have to calculate VGS at minus 0.5. See, here, minus. Here, absolute. Then you can calculate each one for this one. Any question for this? Plotting, see, this is it's like a line. I don't need this plotting because just if you want to draw GM with VGS, it's like a line. We didn't need an exam. Now let's go directly to the skip this. Also, is that important? Very important. Effect of ID on GM. Skip it. And let's now study the parameters. What is these parameters? You know, every time we are talking about parameters, for any system, you know, I absolutely have 6 parameters. VI, VO, II, IO, ZI, ZO, then you have AV, so VO over VI, AI, it is IO over II. I guess this is clear. Now, first parameter is ZI. In GFIT, it's infinity. We defined this before. It's absolutely 10 exponential 9, that's 1000 mega ohm. Where a value is more than, see, until 10, 12, or 10 exponential 15, so in MOSFET. So there is no ZI, infinity. ZO output is this 1 over GOS. In BGT we define we define R, we called RO, same thing here, called RT. So here ZO, it is 1 over GOS. This is given in exam. So don't worry about this one. Now we have Z in and Z out. I don't need this in exam. I will give you. Now, I want to define the model that I'm going to use. If you remember for BGT, we defined model, RE model مثلا. We said this is RE model here. Beta RE, beta IB, B R. Correct? This is define this model for RE model for CE, common emitter. And we define another one for common RE, then alpha I, E, then R. So now let's compare this one with this one. I will go back with you to chapter number 2. Comparison is very important for us. Where is BGT? This is BGT. We will cut and paste together. This is our model. If you remember, I will take this, copy, just a minute. So let's now paste this here. and compare. Yes, here. Control. Oh, what's this? Now let's expand and see. So see now comparison between both. Do you think they are same? Ahmad, do you think they are same? Areen, Rian, everyone. What do you think, Ariane? Ahmed? Yeah, I need your opinion. What do you think, Akadar? No. Okay. For me, I think they are same. Why? See here. Here we have beta RI, here we don't have. Okay. But idea here, see this. This is dependent power supply. Dependent current. Here we have dependent current. Correct, Ahmad? Do you think they are same? Yes. Here we have RO, here we have RD. Same. So this is change beta IB with GMVGS. Ah, same. Here I have beta IB. Here I have GMVGS. So this is the comparison. This is the comparison. Okay. So now see for this comparison here, I have to calculate before beta, then I have IB. Here I have to calculate GM, then I have VGS. So I have to calculate, so exactly same model. Same thing. For example, all DC should be short circuit. You know this. All capacitor, short circuit. Just we are using here super position method. Same thing. And here just to calculate this one. So trick here is how I calculate chain. Here I trick here how to calculate RE. Got where is the trick? In this with me. With me. You have to understand the concept. In BGT, you have to calculate RE. In FIT, you have to calculate GM. This is the trick. If you understand this trick, you will pass. Here it's infinity. Here we have resistance. Okay. Continue or repeat? Continue or repeat? Okay. See now, given GFS 3.8 millisiemens, GOS 20 microsecond, sketch the fit EC. GM here is G forward, So sometimes we can say GM or GFS, same thing. And this RD, it's 1 over GOS. Here gives me GOS in microsiemens. Then you can draw or make this model. Now, start directly to the three models. First model is fixed bias configuration model. You know this model we did before. And C, or the same thing, all capacitor will be short circuit, or DC power will be short circuit. We are using superposition method. I guess you know this one. So now, slowly, we have this model. Same exactly BGT. So here we have something, etc. See, I have here ZI. Here we have value. They take care. Before we said ZI for transistor. Here ZI for configuration. Clear? ZI for transistor is infinity. For configuration, we have value. Clear? This is very important. It's very important. Those are small tricks. Repeat again. This is the transistor. Zi is infinity. This is the system. We have Zi. Repeat or clear? Okay. Now, I guess you can find now the values easy. We solved this example before. Zi here is RG. ZO is this with this as a parallel. Then we need to find AV and AI. So what is AV and AI? This is ZI. ZO it's RD. Sometimes you can ignore. AV it is VO over VI. We can, for example, set here. Same thing, VO here. If I cannot use we cannot use this. If you remember, VO, this is opposite. I solved it before. VO, it is GM VGS in minus. Ahmad, take care. We have what we have. What we have. What we have. What do we have? Ariane. We have, what does mean minus? Do you remember what that mean? What the meaning of minus? Tariq, I guess. Ahmed. Everyone. What do you mean of minus? Reverse. Reverse what? Reverse what? Reverse. Not no, not bias. Focus. Reverse phase. يعني if I have input like this, output will be like this. So that's me, we have 180 degree between VI and VO. Got the meaning of this one? Here we are talking about AC, don't forget. Clear or repeat? I guess you forget this one. So same thing. Common source here. We have before common emitter. Common source here means between V input and V output, we have reverse phase or flip phase or 100 degree between VI and VO. You can see from the graph, and you can see also from this minus. This minus is very important. Clear? Clear? Don't forget. So what we said for BGT is still correct for common source and FET. See here? Okay. VO over VI minus GMRD over multiplied RD. Ahmed, I will compare with this is in BGT in sorry, this is in fit, correct, Ahmed? What about BGT if you remember the formula? ABGT AV was yes minus RD RD not RD, sorry. It was at that time another not RD. RO RC over RE, correct? Correct, Ahmed? So do you think don't forget R 1 over GM? Correct. So do you think this like this? What about same formula, Aryan? Arkadaşlar. Same formula? Yes, same formula. So here, you know, I'm working with you how you can, if you know BGT, how you can find fit. If you know fit, how you can find or define BGT. So I know different meaning, but just for formula. So it is here VO over VI minus RDRO If I can ignore RO because it's really big, so we get this one. It is also here BGT. It is AV equal minus RC over RE. Correct? Any question for this? I guess now it's easy. So what is the problem here, Ahmed, Aryan, Muhammad? TM, what's your name, T? First name. I don't know your name. Excuse me. Tariq is correct, T. Turkey. I'm sorry because you know just I have abbreviation. So Turkey again. See Turkey. Here I have to calculate RE, correct, and BGT. Here I have to calculate what? GM. So in BGT, the idea here how I calculate RE. In GM, how I can calculate GM. This is the tricks. The tactic said in BGT, calculate RE. RE it is in room temperature millivolt over IE. In GM it is GMO 1 minus VGS over VB. GMO. Yes. So now let's start to solve this example together and see how we can do this. Okay, I will minimize this. Now, the fixed bias configuration of sample or example 7 point. So here in this one, excuse me, take care. Here we will start with example 7.1. So return back to 7.1, solve. What we have to solve, draw this, draw this, draw, for example, this or this or this based on the model. So here we have fixed bias configuration. Now, so here, first of all, you have to draw transfer curve. Second thing, load line. Third thing, find VGS. It's very important. Add Q. In exam, you have two questions. Either start from 0 like this or like this one. I will give you directly VGSQ. Clear? So we have two methods. Start from 0 or given in exam. Is it clear? It's very important. So I know here you have 1, 2, 3, or I will give you VGSQ, then you have an IDQ, then you have to start. It's an exam. So we have two ways. First way, start from 0. Second way, start from this one. So now, let's say I give or refine these two parameters, VGS as working point and IDQ as working point. Wait just a minute, who said 0? Ariane? No, not 0. It is given. See with me? Was it 0? Was it 0? Astaghfirullah. Given. See this? Given or not? Can you see? Here, both are given. Otherwise, in exam, you have to start with example 7.1 from 0. Clear for you? Or repeat? So you have two ways. First way, you have to start from 0, 1, 2, 3. Other way is, I will give you. So I will make short for you. Repeat or clear, Ariane. Don't hesitate. Should I repeat? Ahmad, everyone, Turkey. Good, yeah. Now we have determined GM. So we have this model. He gives to me IB, IDSS, VB, and we calculate it. So directly I will hide this. Calculate GMO, calculate GM. This is given here. This is GMSQ or VGSQ is given here, but usually you have to find by yourself. How can I find? Again, repeat, we have three things. First of all, draw transfer curve. Second thing, draw line. So again, chapter 6, chapter 7 until chapter 8. Then find RD. After that, you can find the values. Any question for this? So same thing, Ahmad. In BGT, if you remember, we start with DC, we find IB, then we find IC, then we said IE, it is IC positive IB, then after that find RDE 26 millivolt over IE. I need RE if you remember. Here same thing, I need to calculate GM, so I have to calculate VGSQ, so it is transfer curve, then load line. Okay? Any question for this? Repeat or clear? So easy. Tariq, what is YOS given? YOS given. This is YOS. It's like if you remember back, okay. This is Tariq, this is YOS. I will show you again. Tariq, Turkey, excuse me, Turkey again. Yeah, you are invited to Coffee Turkey with at my office, okay? For this mistake. Sorry for this. See, this is RD, it is 1 over YOS. This is RD equal 1 IOS. Okay, so here it's RD, but usually given to us Y. So if they give to us Y, just flip it. Clear? If they give to us Y, just flip it. See here in our example. Yeah. See here, another question is here. See why I need Turkey. See here, it's RD. See RD, it's 1 over YOS. Clear for you? It's clear for you. Any question for this? Any question for this? Now, another question or another model is self-bias configuration. Same thing, same thing. See, same model. Oh, Jam, say yeah. For BGT, we are lucky. You know why? Because if we have this the key here, the key is here. As you see in self, we have RS, but we have a capacitor. If we don't have capacitor, that we are in trouble. But we have this capacitor, so this capacitor cancel this. So we return back to fixed bias configuration. So same model. So self-bias likes fixed bias. But take care, Ahmad. This is care for ID with VGS. Don't forget. And this is the load line here. This is ID Q VGS. So the difference between first one and second one just in DC in load line. Clear this? Is this clear for you? Tariq. Ahmed Aryan. Just easy, easy. Tick is easy. 1, 2, 3, finished. Okay, now let's go to the AC, last part. I need AC, so AC, see, this is the benefit of this capacitor cancelled RAC. If we don't have, that means it's a big problem for us because everything will change. Now this is the model, RG, RD, RD. So exactly in AC analysis for fixed and self, both are same, no change, and same values, same values. Okay. Now an I bypass, this is cancelled a little bit hard. So we don't need this one C. If we don't have, we have RS, and will be very hard to calculate. So ZO, what is ZO, and what is ZO, and what's AV? See the AV, it's a little bit very hard, so we'll ignore this. Here in our book, he gives to us examples, cell pairs without capacitor. So this is cancelled. If I will bring with capacitor. Last model, it is voltage divider. And just remember your voltage divider here. If I start with, don't forget this is, but again, this is GFIT, so it's ID in channel VGS. This is draw the transfer curve, and this is the load line. If you remember here, start from VDD, then make a line. This is VGSQ, and this is IDQ. Hear this? Did you remember this? I gave you before. Okay. Now let's draw or refine with AC. See, this is the AC. This is the AC. And AC here, just we add, the first one we have R1 or RI. Here we have R just. So the same formula, same thing, everything like it, but just in the first two models, we have RI or RG. Here we have, let's go to the first model, for example, before, what we said it, RG. Here we have R Thevenin. That is only, whereas the rest values are same. CC, AV, AV, ZI, just we have here R Thevenin. So our lecture is repeated. Yes, repeated. Self like fixed like voltage divider. AV same. ZO same. ZI in the first two are same. In the last one is R Thevenin. That is easy. Any question for this? Any question for this? Easy, Arkadaşlar, easy. You can make one paper and write all of these in the same paper. Common gate is cancelled. Source follower is cancelled. We don't need it. See the formulas? Oh, Ahmad is good, I guess. Then depletion type MOSFET. Let's check. Same thing for depletion type MOSFET. Here we have N MOSFET. You know, in N MOSFET we can use in two modes. First mode is GFET mode, and second one is enhancement mode based on, I will draw again. For MOSFET depletion, you remember with me, we have like this. ID VGS, we have, this is tick, 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 tick. Oh, sorry, I did the first mistake. See, this is E until this point, then we have this, don't forget. Then we have load line start for voltage divider. Here start, then we have a cross. So we are working here. So it is GFET mode. If you are with its enhancement mode. This in our mode. So why is this? See in our book, the fix didn't work. This one in example 7.7 gives to us. Again, here in this question, he gives to us every values. So I don't need to calculate anything, just calculate the values. But if I don't know, you have to start with, like I said to you, transfer curve, then you have to calculate load line, then you have to calculate these values. So here we have also capacitor for this one, so this RS will go out. So you have to calculate like GFET, yes. We have R1, R2, that's mean R Thevenin. Then we have, this is AV. Then we have here RD given, RD also given. Bye-bye. Enhancement is cancelled. This is the last topic and last idea. In which page? 506. Enhancement, we don't have any example in our book, so we don't give any. This is after that is cancelled, and here is the last topic for this semester. Here. Is it clear? So what did we study today, or what we studied today? I will write here for students who want to see this video. First of all, we studied GM as a model. We studied how we calculate. Okay. Mathematically, this is important to me. Third thing, we studied the fixed bias defect. We studied self bias defect. We studied voltage divider defect. Then we studied voltage divider MOSFET depletion. That is, any question for today? Ahmed, Ariane? Turkey, sorry, Tariq or Turkey. Yeah, I know it's Turkey. I'm joking. I want to change the weather. We finished our course today. I hope it will benefit for you. I need to ask you about your opinion at the last lecture. Which subject is easy for you? Electronics 1 or Electronics 2? Ahmed, Turkey, Ariane. 1 or 2? Which one is easy for you was? 2 is more interesting. Sure, it's more interesting. Agree with you. One was easier, correct. But where is the problem? In one, it's just introduction. For each introduction, it's hard. Like if you start to, for example, study any language, Chinese language, Turkish language, any language. For first, it will be hard. Then it will be easy for you. So exactly like this. For electronics, it's hard because it's new topic. But if you go deeply with this one, it will be easy for you. So as you said, 2 is more interesting than 1. I agree with you this one. Any question for this course? After midterm Turkey. So you have chapter 6, 7, 8. What I give to you. Also, I uploaded to you some questions and answer for this question. You can see on the UBS. So you can download and see it. Clear?